Greetings everyone. This is regarding the problem statement we are dealing with for the SIH 2024. The problem statement title is developing an ML model based solution to refine the captcha for the UIDI website. So let's deep dive into the problem statement description so that we can know more information about it. In the problem description, we can have idea that the UIDI is currently having a captcha system to segregate the entry between the human and the bot. So that it can prevent those device attacks and all those things from those bots. So UIDA felt that the captcha system is becoming a barrier for the smooth interaction between the users and the portal, so that they want to remove that captcha system and want to redefine those captcha system with something better. Since the UIDA is planning to remove that captcha system, they want an AML model to differentiate between the human and the bot, whether the interacting system is human or bot. If the interacting system is human, they may grant the permission to access the website. If the interacting system is a bot, they have to deny the service of the website, so that they can avoid those DOS attacks. So they have clearly mentioned the objectives that if there are any environmental parameters that needs to be captured, they have to list them all. And if we are unable to do that in a fully automated manner, so we can have some user data also with few minimal interactions with the portal, so we can collect those data and we can use those data also. And front end can be of anything from the React, TypeScript and Flutter. So regarding the backend, we have to develop an ML model that can easily be integrated into the UIDI website. So that's all regarding the description of the problem statement. Now let's look at the proposed solution. So our solution was a captcha-less system for a better India. So the proposed solution is that we are going to develop an AML model. So in the AML model, we have a model that can differentiate between the bot and human without having any human interaction. For the AI behavioral patterns, we are going to use custom AI models with Next.js and Flutter for the capturing the environmental parameters. For the rule-based system, we can filter the bots between we can filter the users between bots and humans with those environmental parameters, and we can block some known bots which having some IP address and all those things. For the random forest model, we have to analyze the environmental parameters with the already existing dataset, so that we can segregate between the bots and the humans with the machine learning models. And if the rule based system cannot identify the bots, we can use that AML model. So this is what we are calling it as a multi-layered model, so that if the first model has failed to detect between the bot and the human, the second AML model will do that for us. So regarding the meta learning with GAN, as the days pass by, the bots are also getting advanced, and they are going to crack those softwares. So we are using meta learning to detect the advanced bots with sophisticated pattern analysis for complex cases. Regarding the privacy compliance, we are not going to collect any kind of data from which is private to the user. We are going to collect only the mouse movements and keyboard typing speed and all those things from the browser environment, so that there will be no privacy complaint regarding the user's privacy. And how we are going to address the problem is that we have successfully satisfied that what the problem statement is given, that is the seamless user interface. They do not want any active captcha system, so that we have removed that captcha system from the from our project, so that we are going to work only on the environmental factors and multi-layered security. So like as we have discussed, we have two layers, so that one is the rule based system. If there are any known bots, it will automatically block those bots. If there are any if there are any new IP addresses came, it will cross check with the AML model, and after getting the result from the AML model, it will decide to grant or deny the permission. And privacy adherence, we have already talked. And regarding the innovation and uniqueness, we have used the multi-layered security, not just using the AML model, because AML model it has to be run somewhere in a server or something, which incurs some cost. So we are using since we are using multi-layered security, if there are any some known bots that are already there in our list, we can block them without going to interact with the AML model. So that will that will lower the cost somehow. So our solution can be integrated with cross platform, so that the proposed solution can be integrated anywhere between the web and mobile and all those applications of UIDAI. So regarding the technical approach, we are going to use Next.js for the front end and Flutter 3 for the cross-platform development. And regarding the backend, we are going to use same the Next.js for the modular structure, while fastifying the creating high performance and scalable APIs. For the database, we are going to use MongoDB, since it is flexible for storing any kind of data, and to manage the real-time data and scale. We can scale out the database as the data sets are increasing. Regarding the machine learning, we are going to use the scikit learning to train the models, and for the deploying of those models, we are going to use AWS SageMaker for the seamless integration and scalability. Regarding the analytics, we are going to use Google Analytics to gather the real-time user behavior, including click patterns and all those things, to distinguish between the bot and the user. Regarding the process flow, the user will try to log in into the UIDAI website in the front end itself. From the front end, we are going to collect all those data of environmental parameters like the click patterns and the typing speed and mouse movements and all those things. We are going to collect from the front end part, and we are going to deliver to the our multi-layered ML model. If the IP address and all those things, we are also going to collect. So if the IP address is matched with any of the IP address with the list we are going to have in the bot list, it will automatically going to reject. And if the first layer was failed to do so, it will pass the same environmental parameters to the ML model. So then the ML model will cross check with all the data sets and all those things, generate a 0 or 1 output, whereas 0 stands for the human and 1 stands for the bot. Output is 0, the human is interacting with the website, so that the portal access is granted to the website. If the output is 1, that a bot is trying to access the website, so we have to deny the access to the website. Regarding the feasibilities, as described in the problem statement, we have to gather minimal data from the user. So we have done that with minimal interaction, gathering the passive data only, like the mouse movements and typing patterns, seamlessly with minimal user effort, so that user don't have to enter those any captcha and all those things anymore. Regarding the cloud scalability, since we are using the cloud platforms to deploy our ML models, and we are going to use MongoDB for the NoSQL database, we can scale out the things as the data increases, and the traffic if the traffic also increases, we can scale out that AWS SageMaker also. Regarding the continuous improvement, since it is an ML model, it is not going to be perfect from the day one itself. We have to constantly monitor the ML models and train accordingly for the better output. Sometimes if the user if the human is trying to access the website, sometimes it may reject the that access also, so that we have to train the model so that it will produce correct outputs. And regarding the viabilities, we are going to use the seamless UX for the using any kind of age groups and cost efficiency. AWS serverless architecture, we can adjust the cost based on the traffic, so that we are not going to pay for not we are using. And minimal user impact, it will only collect the data which is not going to disturb the users. Regarding the challenges we have faced during the making of the solution is that the model complexity, since we are using a hybrid model, we have to gather huge data sets for the we have to for known bots, we have to gather huge data sets, and for the ML model also we have to take thousands of entries for making the data set. So that's where we have encountered some problems. And regarding the real-time latency, if the traffic is more, the real-time processing may introduce some latency, affecting some user experience. Regarding the data accuracy, like as we have discussed before, if the data is insufficient and some new patterns may arrive to the website, so that may lead to some inaccuracies for defining the bot and the human behavior. So that is all the challenges we have faced during making of the solution. So what the strategies we have used to address those challenges was the model complexity. We have used AutoML and MLOps tools for the efficient model management, and for that real-time latency problem we have used some edge computing and content delivery networks and serverless architecture from the cloud platforms to reduce the latency in high traffic environments. Regarding the data accuracy, we have enhanced the data with synthetic data and data augmentation, and also we have taken the support from the Cloudflare bot management to address biases. Regarding the impact and benefits, for the potential impact on the target audience, we have eliminated that capture system, so that we are going to provide a seamless user experience. For the increased accessibility, if the capture system is there, some kinds of blind people or some with visibility issues, those they cannot easily access those capture systems, so that we have eliminated those issues as well. And adapt to security, now we are going to since we are going to use AI driven bot detection system, so that security issues can be addressed in a more efficient manner. Regarding the benefits of the solution, since we are using the AI driven verification, we have enhances the engagement and service delivery. It can reduce the wait times as well, and streamlining the access. Regarding the cost and resource efficiency, we are going to since we are going to use the serverless architectures and AI based optimization, it will cut the operational costs and improve the energy efficiency as well for the capture services. We have provided that inclusive digital access as well, so for those kind of people with visual, motor and cognitive impairments, they can also easily access the website without any issues. As far as the research and references is concerned, for the research part we have used Wikipedia for knowing about the bot, how they are going to behave and how they are going to do the DDoS attacks and all those things, and about the capture system as well, and what are the capture systems available for the alternatives which are currently having in the UIDA website. And for the machine learning, we have seen some publications of the research gate. And for the references of our project, we have referenced from the React documentation and the GitHub as well. And for those serverless architectures and those kind of AWS SageMaker and all those things, we have used the AWS documentation for the developing and deploying of those applications. So let's see a quick demo about our prototype, so that we can have a better idea about our solution. This is our demo, and now we are going to run the development server. So this is the sample page we have created for our development purpose, and now we are going to enter the Aadhaar number we are an human. And now if we click the submit, it will successfully log into the UIDA website. Now let's do the same task with the bot. If a bot do the same thing like how it did, whether it will give the access or not, let's see. Now we are making a bot to do the same thing, and now it is denying an access. Since the keyboard typing speed is high and the mouse movement is also not similar, it is denying the access. So this is all about the problem statement and the proposed solution. Thank you for watching this video.